Okay, today our lesson is quadratic relations and their graphs. A quadratic relation, whenever we say quadratic, it means that the graph is always a parabola. So I have a parabola with the quadratic relations. So we have always quadratic. The graph is always a parabola. So we have three forms of a quadratic relation. The first one we'll see is if I have y equal to ax minus h squared plus k. This is the simplest one because it's already given the vertex. So the vertex is already 8k, so I can start always graphing the vertex. So a typical example for this one, let's say we have y equals 2x minus 1 squared plus 3. In this case, the vertex is 1, 3. The vertex is 1, 3. The simplest point you can find is the y-intercept, or I can find another point if I want. Y-intercept will be 2, 0 minus 1 squared plus 3, which is equal to 2 times 1 plus 3, which is 5. Therefore, my point is 0, 5. To find another point, which is symmetrical point, I visualize the graph first. So I take x coordinates, y. The vertex is 1, 3, which is here. The y-intercept is 0, 5, which is around here. This is 5. So this is a symmetrical line of symmetry. So I go exactly the same number of units from here to the other side. So since this is 1 for x, I go 1 unit, I add another unit to the x coordinates of the vertex, which is 2, 5. So I need just 3 points. Yes, this is sketching of the parabola. This is when it's given in vertex form. If I have it in another form, which is called x-intercept form, where r and s are x-intercepts, which is r0 and s0. These are x-intercepts. This is s. So let's see an example. Y equal to 2, and then we have x minus 1 and x plus 3. We have two x-intercepts here. X-intercepts are whatever makes this equal to 0. Therefore, x-intercepts are 1, 0. It's not 1, 3. 1, 0, and negative 3, 0. These are x-intercepts. And the vertex is always in between the two x-intercepts. Therefore, the x-coordinate of the vertex will be 1 plus negative 3, which is average of the two x-intercepts, which is negative 1. To find the y-coordinate, I substitute x equal to negative 1 into my original function. 2, negative 1 minus 1, negative 1 plus 3, which is 2 times negative 2 times 2, which is negative 8. Therefore, my vertex will be negative 1, negative 8. So now we have the vertex and the two x-intercepts. So it's easy now to graph it. So I can go to this is the vertex is negative 1, negative 8. Let's say here. The two x-intercepts are negative 3 and 1. Therefore, I just do the graph. This is a graph. So I have the graph with the two x-intercepts and the vertex. The third kind of equations we have is when it's given in standard form, we call it, or general form, bx plus c. In this standard form, we know only the y-intercept. Y-intercept is always the c, because when x is 0, 0, c is remaining. So y-intercept is c. Now we have to find the vertex. Let's say an example. Y equal to 2x squared plus 8x minus 1. To find the vertex from standard form, I have to complete the square. Complete the square means I take the 2 out, x squared, 8 divided by 2 is 4, and then I have 2. I complete the square inside the bracket. So x squared plus 4x, half of 4 is 2, 2 squared is 4, plus 4 minus 1. The first three with the positive 1 are always x plus half of 4 squared. I take the minus 4 out by multiplying it by the outside number. 2 times negative 4 is negative 8. Therefore, 2x plus 2 squared minus 9. So let's visualize now another point. So the graph, I have at least 2 points here. The vertex is the most important one. The vertex is negative 2, negative 9. Negative 2, negative 9, let's say it's here. And then I have the y-intercept. Y-intercept is like negative 1, because the y-intercept is a c value. Negative 1 is here. So this is symmetrical always. It's a line of symmetries. Therefore, I go to another point. Y is negative 1. Since x goes 2 units here, I go another 2 units from here. So negative 4, negative 1. So I have 3 points. Negative 4, negative 1. And then we have the graph. So these are typically the 3 types of parabolas we have. We are given in 3 different forms.